Prime factorization. I can factor whole numbers and express a whole number as a product of prime factors with exponents. So we've been working on factoring of whole numbers. So today we're going to write a whole number as a product. Product means multiply of prime. So prime, we want to get numbers that only one in itself can go into. And I want to do that with exponents. So let's take a look. Write your line down and let's write the word factor. Again, two numbers multiplied together to get a product. So like the factors of 14 are 2 and 7 and 1 and 14. So let's make a list of factors. You can either list it out 1 and 28, 2 and 14, 3 and 3 goes in. Otherwise, we've been working on our T-charts. So let's do 28. 1 and 28, 2 and 14. So let's think, does 3 go in there? Well, let's add them up. 10. Does 3 go into 10? The answer is no. 4 go in there. Yep. 4 times 7 is 28. 5 doesn't go in there because it doesn't end in 5 or 0. 6 doesn't go in there because 2 and 3 don't. And then we're back to 7. So there's all of our factors of 28. I'm going to have you stop the video and try to do the factors of 72. Stop the video now. All right, welcome back. Let's see. 72 is a hard one. There are a lot of factors people forget, so let's see how well you did. 1 and 72, 2 and 36, 3 does go in there because it adds to 9, so it's 3 and 24. 4 is one that people forget because it's a hard one, so 4 goes in there 18 times. 5 does not go in there. But 6 does because both 2 and 3 do. So 6 and 12. 7 does not go into it, but 8 times 9 is 72. So there's an easier way in case you missed factors, and that is called prime factorization. It's a number written as the product of the prime numbers. So the product multiply of primes. So let's get that definition written in our notebook. And let's look at that same number 72. If I break 72 down to any of these factors, it doesn't matter which one of these factors you use. I'm just going to break it into 8 times 9. Now remember, we're not adding, we are multiplying. Product means to multiply. Now you have to ask yourself, is 8 a prime number? The answer is no, because I could break it down to 2 and 4. So let's keep going. Can 2 be broken down? The answer is no, so let's circle our prime numbers. But 4 can still be broken down into 2 and 2. So I'm just continually making what I call trees until I get all of my prime numbers. So now let's break down 9. 9 can be broken down into 3 and 3. And yes, 3 is prime, so I circle them. So there's a factor tree or prime factorization. We've broken it down into prime numbers. What you need to realize is I could go 2 times 2 times 2 times 3 times 3, and if I did that, I'd get back to 72. So let's write this in expanded form. Remember, we have to expand it out. So we're going to write 2. I'm just going to use the dot for multiplication, times 2 times 2 times 3 times 3. Now this one happened to work, but you always want to write it least to greatest. So now let's write this in exponent form. Our base in this first number would be 2, and we count up how many 2's are there. There's 1, 2, 3. So there's again 2, the number 2, there are 3 of them. And then we're timesing that by the number 3, and how many are there? There's 1, 2. So if we used order of operations, 2 to the third power means 2 times 2 times 2, which is 8. 3 to the second power, which means 3 times 3 is 9. And 8 times 9 gets me back to 72. All right, I want you to try 180. I'm going to get you started. anything ending in a 0. Think about your divisibility rules. 18 and 10. Stop the video now and continue till you have circled all of the primes. All right, let's check your work. Now again, you can divide 18 however you want. I'm going to do by 2 and 9. 2 is prime, so I circle it. 9 is not, so I have to break it out again until 3 and 3. 3 is prime, so I circle it. And now I need to break down 10 into 2 and 5. 2 is prime, so I circle it. 5 is prime, so I circle it. Now let's write it in expanded form. So I have 1, 2, 2 2's, because I always want to write it least to greatest. So 2 times 2. And now I have a 3 times a 3 times a 5. So there it is in expanded form. Now let's do exponent form. So you have to ask yourself, how many 2's do I have? I have 1, 2. So I write my base, and I have 2 of those. I have the base of 3, and again I have 2 of those. And I have the base of 5, and you can either write to the first exponent or not. I want you to try 98, and we'll check it tomorrow in class. And then you can work on your homework.